Hi, my name is Wyatt. This is Alec and Jared, and our project was using MATLAB to control a sonar. So our design specifications. We ultimately wanted a ultrasonic sensor and a servo to be controlled by MATLAB and an Arduino in order to take plots from direction and distance and then send it back to the computer.
And so the next goal for us was to get the initial scan and the secondary scan, save the data for plots, then plot them against each other so you can see the changes in the object's position whenever it got scanned.
So I don't know how well this is able to be seen. This is our block diagram of the circuit. So far we have the computer and the Arduino, which was what controlled the circuit. These are 3 AA batteries, which were in order to help the Arduino power the servo and the ultrasonic sensor, because whenever it ran low on power, it would start to have anomalies occur in the plotting. We have our ultrasonic sensor here and a servo, and then we had an RGB that was also connected, and this was in order to tell the user what phase the code was in based on the color changes, which will be talked about later.
And here you can see the ultrasonic sensor on the very top, and you can see the RGB LEDs purple. That means that's an indication that it's still turning. But once it stops completely running the code, it will turn red. But in this case, we start scanning for the secondary so we can compare the 2 graphs. And here's the microserver. And I put my hand near it so you can see the change in position. Here you can see the box for an ultrasonic sensor was just laid out. So for both scans, it didn't move. You can see it's in the same spot, the red and the green lines. Here you can see the initial scan, the red lines. It's all the way stretched out. That means nothing was blocking the sound waves from coming back. And here you can see the green lines are all the way pushed back. That means something was scanned. In this case, it was my hand.
Alright, so the code has 3 main steps versus the initial scan, which every 2 degrees it does a ping and receives it and checks the distance, and when it receives it, it has a difference up to 20 inches. And after that, it does a subsequent scan, which after that, both scans do save a table of the data received. After that, it compares and displays the data by comparing first by checking each value if they're the same or not with ones or zeros, just a true or false value, and applied to each table value. And after that, it displays the data using the true or false to determine where to turn the line red or green, and using a combination of both data sets.
So the bill of novelties for our materials, all we used was a microservo, Arduino, ultrasonic sensor, and RGB, which actually made it to where it was relatively cheap. However, we had to buy these items in bulk. They were not just buy one items. So it came to a total of $51.
And the novelty of our project compared to others involves, well, we use an ultrasonic sonar that is capable of detecting movement quite quickly by doing a very quick scan. And unlike radar, which uses radiation, we use sonar, opted for using sound instead.
Here's our list of references, and that was our project. Thank you for watching.